We are here after this event in which Professor Monaghan has been appointed as honorary PhD by Universidad Politécnica de Madrid, UPM. And well, the objective of this interview is just to introduce Professor Monaghan and his career and what the meaning of this appointment is for him and for us. So, to introduce a little bit the topic, Professor Monaghan will be appointed honorary PhD because of his works in computational fluid mechanics, which is basically numerical techniques used to simulate the motion of fluids and the loads due to fluids and all these related topics. So to start the conversation, I think that, of course, when we have this honorary PhD, in the end is a triangle between three things: the university, the topic, and also for sure the person that is appointed. So coming to the topic, you did your PhD in Cambridge in the 60s on astrophysics and plasma physics, developing theories on these topics, and then there was no, basically, computational mechanics was just starting. No? The first papers, the first articles on this topic were being released, and I presume that by then all this the use of the computer as a tool to solve a physical problem was something like not so natural as today. But you have something to discuss?
Well, it's true, but you can backtrack a bit because I was born in Western Australia in a small country town of 3,000 people, and we had no mobile phones, no TV. We hardly ever used the radio, and we just used to amuse ourselves in our own way. And then when I went to the university, it turned out that there were no computers there because the only computers that had been invented were in the Second World War, and the governments controlled them. So if you wanted to calculate, you might remember there was something called a slide rule.
Yeah.
Or if you had a big calculation, there was a mechanical calculator. And I liked all of those. But after the university, I went to work with a government scientific research organization, and they had access to a computer. It was built in Australia. It was as big as this room. Your viewers can't see it, but this room goes back for about 25 meters. And so there was this huge computer that was very slow, and I loved it. I thought this was the most fantastic thing. And after that, more computers were built, and when I went to Cambridge, there were computers there available. But you had to get up, they were mainframe computers, big, like this room. And you had to get up at 5 a.m. in the morning in order to be able to use them, usually. And in fact, Jenny over there, my wife, we actually met in this computing room in Cambridge. You see, love comes sometimes from computation.
Well, now...
In any case, I started working on these, and at a visit to Cambridge some years later, I started working on computational fluid dynamics seriously. Before then, it wasn't possible to do much. Dynamical problems where splashing fluids or aircraft crashing into the ocean, you couldn't simulate that. There was just no possible way of doing it. And in astrophysics, the way stars are born, that was also a difficult and important question, but the computational fluid dynamics could not handle it. And
so you developed this technique in the mid-70s?
That's right.
Smooth particle hydrodynamics?
Yes, with my friend Bob Gingold.
Yeah, you and Bob Gingold trying to tackle, no, or to develop techniques to look into, basically into astrophysical problems then.
Yes, scientists are...
And also with the view on using this for the computer already, or, I presume.
For using the computer. And you find yourself in the position where you want to solve a problem, and you're trying to find a way of doing that, and you need to invent what's called these days an algorithm.
And there were these kind of very structured techniques from the 60s and 70s.
Yes.
And you and Bob decided that something new was necessary to tackle these complex dynamics of the stars and the galaxies.
Correct. And as it turned out, it was quite good for calculating the complex dynamics of a wave breaking on a ship.
But that came later, no?
Oh, much later. I wasn't thinking about that at all. This often happens. People have an idea about something, and then somewhere else it can be used. The people who invented the laser didn't realize you were going to have CDs and laser readers. They just happened to think it was interesting and a way to solve a particular problem.
So in the early 90s, you published these papers in which you started to use this technique, smooth
Yes.
particle hydrodynamics,
Yep.
to solve water waves and interaction of waves and solids,
Well,
floating solids.
I think the
And then-
first paper was, I had to look up to find out about wave makers producing waves, and some other problems which I thought were interesting. And it turned out that engineers were quite interested in this too.
Yeah, and also it turned out also that, for instance, this Spanish company, Next Limit, decided to use these techniques
Yes.
to simulate the special effects in movies in which fluids were involved.
Yes, actually they won an Academy Award.
Yeah, and that was in the late 90s, almost in the year 2000.
But the way in which it started is interesting. I went to a lecture in archaeology, and they were talking about the way the Minoan civilization disappeared. And could it have been from a tsunami generated on the island of Santorini and propagating to Crete? And I said to one of the archaeologists, would it be interesting if we could calculate this? And he said, oh yes, archaeologists need hard facts. So I started, well, that night I thought about it, and I thought, well, yeah, I can calculate these things. And we set up a wave tank in a laboratory eventually, and eventually went to Crete, and we did various calculations on this. But that's the way it started with the Minoans, actually.
Because you have interest on many topics, no? Astrophysics, now you're working with people doing solid mechanics, hearing some problems later, no?
Yes.
Fluid mechanics in water waves.
The
so
world is-
your background is quite...
Antonio, the world
Extensive.
is full of interesting problems,
yeah.
just as long as you have time to solve them, actually. But they can be solved. That's the thing, you know, that they can be solved. Fracture in a building, or fracture in asteroids out in the solar system. They're all interesting problems. Waves breaking on a beach. We could go on and on talking about these interesting
and then
problems.
you visited Madrid in 2002 to have a conversation with Next Limit. Also, you were
Yes.
you had the chance to go to
Well,
Rome.
you introduced me to Next Limit, actually. And we went there, and they'd already started doing very interesting things. And I had no idea that the film industry and the TV industry were interested in this kind of computational fluid dynamics. They have complicated problems too. Think of Lord of the Rings, Gollum falling into the lava. That's a very simple case for us, but it makes that part of the movie look better. And
you have had the support of some people during these years, no, to develop the method. You have been moving from Monash, doing these research lives in Cambridge with other...
The big push has come from people like yourself, actually, who are interested, first of all, in problems in marine engineering, but all of those involve, well, a simple example, the flow is, say, on a ship, it flows over a solid plate. You have to think about what kind of conditions this produces. You and others have analysed these very carefully, and I think the big push has come from engineers, actually, which has been a wonderful thing. I'm not an engineer, but I kind of understand what engineers are trying to do.
Yeah, with this, with the knowledge, no, on basic
Yes.
science, you are able to talk to everybody. No?
Well,
not to everybody, but most of mechanical engineers, naval architects,
Yes.
aerospace engineers.
Well,
Because at the end, we are all in the same physical
It's true.
framework. No?
in
Newton.
Australia, we speak about enabling sciences, like enable you to do things like physics and chemistry and mathematics. And when you know those quite well, you can move from one to the other and talk to the people who work in those areas. I think it's wonderful how you can just look around and see people doing interesting things. We've just had a conference in Orense, and the people there are doing an astonishing number of things. Digestive processes, how ships move, how water shifts things around, scouring of sand from a harbour. It goes on and on. If we lived long enough, we could solve all these problems. But there are plenty of problems for students. Plenty of problems for students.
Students at school, they are taught basically solid mechanics, in which they learn how a big object falls down a slope, or how two balls bounce against each other. This kind of rigid solid, and they don't, well, that's because also it's a bit more complicated, but they are not taught fluid mechanics usually until they are at university level. But of course, fluids are very important in life. If you have to move a car, in the end you have issues with fluids, with combustion. If you, of course, the car itself is moving inside the fluid. And when you are in a ship, you have to deal, of course, with the forces due to fluids. And there have been, through the years, like analytical approaches to these matters. And
well, if you go back to Euler and hundreds of years ago, then of course there were simple problems they could solve. But if you could examine your body, you would see blood pumping around the heart, blood going in other parts. It's an interesting fluid to try and deal with. Anybody that...
These days we saw in Orense people trying to simulate issues with the heart.
Yes. And
the valves and...
That can be done. There are biological problems which are not really solid, not really liquid, but something in between. And I think they're very interesting problems, but you need to talk to biologists and zoologists to understand what their particular problems are.
We have the issues when they have to transport natural gas made liquid from all these reservoirs or from all of these countries that produce them, in Australia, in Qatar, and they have to put these things, to put this liquid into a
container
ship and move it around. And
when they move it around, they put it on the ocean. The ocean has storms. The ocean gets rough. So you've got a ship. It's not going like this. It's going in a complicated way.
Yeah,
and that has an effect on the gas. Also, they stop off at different ports and deliver part of it. So now the tank is half empty. And as you know, if you've got something that's half empty, the shaking gets quite violent. And that's an important issue for the stress and what happens to the fluid in the boat. Yeah, well, I was going to say that these kids at school, they do learn about sort of particles moving around. But actually, in our computational methods, we have particles moving around. It would almost be easier to teach them about the smooth particle hydrodynamics method than it would be to teach them about analytical fluid dynamics, solving the equations. But actually they need both.
Yeah, because sometimes also in school we are not, we don't have this perspective about conservation of physical quantities that are in reality the laws. No, we see this. Sometimes when we are taught these things, we are not seeing them from the conservation point of view, which in the end is where the laws come from, no? Yes.
But there are many opportunities for problems that only require discussion with these kids. I'm sure you could teach them much about fluids. However, let me confess something. I have never taken a fluid dynamics course at university. I've never taken one. The only time I've done fluid dynamics and solved problems in fluid dynamics is in research. So I'd almost say from that if you're prepared to work hard and you are really passionate about some problem, then you will learn how to do these things.
This would be a message you would send to our students. You would say to our students that they can work hard in a topic and,
yes,
and they will likely succeed.
Yeah.
That hard working is important.
Yes, absolutely. If you wanted to be as successful as Rafa Nadal, you have to work hard. This guy doesn't just sit around and go onto a tennis court and win a match. He's practicing hours every day.
But also he has a good team around him, no?
Well, he does. I mean, he's a special case. But he didn't always have a good team around him. When he was much younger, I think he only had his uncle or some relative. And still, you still have to work. So you have to think about that. Even in a university, universities don't start out great and famous. Cambridge wasn't great and famous. Harvard wasn't always great and famous. They had to work at it. And the students in there had to work. And the staff had to work. Even though they're smart, even though they have talent, you still have to work to be a champion.
There are some challenges that the world has to face now, no? In which all this knowledge that we are generating in universities may be important, no? Climate change and energy and many other issues.
Well, we have problems that we can analyze many of these things rationally, but whether or not politicians will take any notice of it is another matter. Sometimes I'm saddened by the fact that politicians seem to be incapable of rational argument about scientific matters. They expect us to give exact answers. And quite often you can't give exact answers. And this is something that we know about, that results are not going to be perfectly accurate. Politicians don't seem to understand this. I don't know how we could change that. We're not going into politics because we prefer to stay in the academic world. Much nicer, I can tell you.
At least in the SPH community, the Spaniards are not doing bad, no? With this group in University of Vigo and with our
and here, actually, here, they're doing very well. Actually, it's quite interesting that they're doing very well in the application to practical problems in marine engineering. And you have a group like Victor Gonzalez Next Limit that is applying this very successfully, first of all to movie problems, but he's now using this in industry. And these are all particle-based methods. And I think, well, Spain must be one of the best. The fact that that company got an Academy Award is already indicative of that. Just keep doing what you're doing, and the more support you can get from the university, the more chance you have of really standing out in the world.
So your research during all these years has had impact in quite a wide range of
Yes.
of fields, starting of course from astrophysics, in which the technique is still one of the top ones used to simulate, to model astrophysical problems.
Yes, like cosmology and star formation and
but
so on.
also in other engineering topics in which, for instance, multiphysics, you need to model heat conduction, you need to model fluid mechanics forces and loads, in which all these complex physical phenomena.
Well, people are dealing with volcanoes, both the eruption and the flow of lava. As the lava flows, it cools, it becomes solid on the top. At the front, it's trying to break through the solid that is forming. These are interesting problems. And if you lived in Iceland, you would be thinking about glaciers more and how ice moves, how the cracks form. It's a fantastic set of problems.
And are you somehow happy about receiving this, having received this appointment from this university?
Well, it's a very great honor. I couldn't help but be delighted that for this recognition, but also that this is a very good university, and I'm proud to be part of it in this way.
We have paid through the years, I think, a lot of attention to basic science in this university. I mean, the training of the students in basic science has been good, and actually you are not an engineer, no?
Correct.
So this recognition is granted to a person that is not an engineer, but of course creates tools and techniques that are used by engineers. And one of the kind of the landmarks of this university.
I can when I try think like an engineer.
one of the landmarks of this university has been a strong background on mathematics and physics that our students get this strong background.
Well, I think that's very important, actually.
And I think it's very important also to try to make like critical mass with the basic science people and the more applied people, no? To solve problems. That is something that sometimes we don't do so well.
You only need a few outstanding people. For example, I think probably 10 or 20% of the people who have that are now overseas, but if they could be here, they would make a big difference. As you probably thought about, if you were managing Real Madrid and you wanted your team to win, and you're back in 1950 when Miguel Malmo was in charge of organising Real Madrid, he was looking for the best players. And if they were Spanish, good. But if they came from Germany, that's okay, we'll try and hire them. If they come from France, we'll try and hire them. We want to get the very best people. And Real Madrid is now famous because they looked for the best people to join their team and then made it easy for them to work in the team.
And once you have good people, then other good people are
they're attracted.
interested.
They're attracted. And it's good for the students too. Good students want to come because they see in the press, by which I mean it may be YouTube, but it may also be just ordinary TV, that interesting things are being done. And they're being done here. And I think that that's a way in which you get good students, and good students eventually go out and do good things in industry, but some of them stay at the university and they mentor the students coming.
And which is your view of Spain from abroad, like in general from the country? Because at the end of the day you have been visiting us already a few times, no?
Yes.
Have you seen any like interesting transformation in the country?
Well, I haven't really seen interesting transformation. Actually, it's amazing that we drove yesterday from Orense to Madrid. The countryside looks in some respect like parts of Australia that I've been in. But anyhow, well, the people are actually, I think, quite creative, and there are things that can be done. But I'm not a specialist in looking at these things. But
you saw this train that they are building, no? Which is also a nice fluid dynamics problem, the aerodynamics of this machine.
Yes, well, the technology of that is quite competitive because the French and the Germans and now the Chinese are also building this kind of train. But it has advantages for your community to have good transport. It's advantages for your community to have good supplies of energy, properly integrated. Whether it's, if it's electricity that you generated in a way which doesn't affect climate change or has a minimal effect on climate change. Seems to me Spain is doing that. And that's a plus. I think the natural advantages that the country should seek are the intelligence of the people. I take a country like Singapore that has no natural resources at all. In fact, when it started, it had no water. It had to get water from Malaysia. But they've now made a high-tech country.
They have put effort on education, no?
Yes, tremendous amount.
People
Science and engineering, and looking for ways in which it can be commercialized, but not forgetting that you have to support fundamental research. It can all be done here, and still have good ham and good octopus, all of which is a nice part of the country.
We are very, very proud of having you as honorary PhD by this university. And if possible, we would like to ask you to be somehow our ambassador in the world.
Yes?
Yes, just to spread the word about the good things that this university has, and to help us to improve the university.
Well, it'd be natural for me to, if the subject came up, to speak about it. There may be some occasions when I will use Spain and this university as an example for how things should be done.
Yeah, we have to do things better, but of course there are some things that are already not so bad here, no?
You know, I think that's true. Just as if you were to go to the headquarters of Real Madrid, they're thinking about how they can play better.
Yes. Okay, thank you very much, Joe. This is your home now.
Thank you.